Hello everyone. In this video we're doing activity 7.3 and this is another independent measures t-test where we're going to be looking at two separate groups and comparing scores in those groups. So in this example it's an anchoring and adjustment example, kind of similar to activity 7.2, and in this case we're looking at what sort of advertising is given at a store and how that advertising affects sales. So in this case, people are shown signs at a store where it either shows the price of a sports drink as 10 for $10, or they also see at another time there are signs that say 5 for $5. Right? So we're wondering if those different anchors on how many you should buy actually affect how many drinks people purchase. So we have two groups, a low anchor group and a high anchor group. Right now the data file is just set up as ones and twos. So let's turn those ones and twos into numbers or values that are going to make our output a little easier to interpret. So I'm going to click on groups here. I'm going to change it. Group 1 is going to be our low anchor group, and they were asked about it being 5 for $5, or the signs were 5 for $5. And our high anchor group were shown signs that said 10 for $10. Okay, so now our output will come out labeled like that rather than just ones and twos. Now to do an independent measures t-test, we're going to click on the t-test menu and ask for independent samples t-test. So this data file only has two variables in it. Our dependent variable is sales, how many actual items, how many drinks people purchased, and then the grouping variable. And the grouping variable is whether they were given that low anchor of 5 or the high anchor of 10. So with our independent t, we're going to ask for a mean difference with confidence intervals, effect size with confidence intervals, descriptive statistics, and descriptive plots. Now before we look at our output and interpret it, we need to decide which statistic is appropriate. And that is, have the assumptions of the independent measures t-test been met? And a really important assumption here is homogeneity of variance. And that is, are the two standard deviations for our two groups estimating the same population parameter? So I click there on homogeneity test under assumption checks. And that shows me here the homogeneity of variance test, Levene's test. Right? And what that test is doing is comparing these two standard deviations. Right? It's comparing the standard deviation of 2.39 and 3.29. We want to know are those standard deviations pretty similar? Are they likely to be just due to sampling error? Or is that a real difference that we should be concerned about? So our p-value for the Levene's test is 0.32, right? Which shows us that these data are consistent with the null hypothesis that those two standard deviations are really estimating that same population parameter, which means we don't need to be worried about that assumption, right? The assumption is most likely met. And so we're going to go forward using the standard students t-test. Right? In this example, we're doing a two-tailed test, so our hypothesis is set up as group 1 and is not equal to group 2 as that research hypothesis. All right, so our student t-test is negative 3.3 with a p-value of 0.0026. That's comparing these two means, 6.0 and 9.47. Right. It looks like the difference between these two groups, our mean difference is negative 3.47. The p-value is 0.0026. That difference is unlikely to be due to sampling error. That's pretty strong evidence against the null hypothesis. Next, we can look at the 95% confidence interval. This first confidence interval is around the mean difference. So in raw score units, our mean difference is negative 3.47, with a lower bound of negative 5.62 and an upper bound of negative 1.31. So we're 95% sure that the true mean difference in the population is somewhere between negative 5.62 and negative 1.31. Now, if you also want to look at this in standardized units, you look at Cohen's d. So Cohen's d, our effect size, is negative 1.21, which is a big effect. We're ignoring that negative sign. The negative sign is just based on what direction the two means were subtracted. Had we subtracted them in the other order, we would have had a positive effect size. Right? But 1.2 is a large effect size. Our 95% confidence interval shows us we can be 95% sure that the true value for that is somewhere between negative 2.03 and negative 0.35. Right? Again, a really wide confidence interval. And the reason for this is a very small sample size. Right? In this case, we have 15 people per group, which just isn't a lot of people. If we want a narrower, more precise estimate of those population parameters, we need to have a bigger sample size. Okay. For right now, what we can conclude is that, well, the mean difference appears to be a real difference. It looks like people have higher values in or bought more when they saw the high sign than the low sign, right? When they're told about 10 for $10 rather than 5 for $5. Right? And that difference seems to be unlikely to be due to sampling error. The effect size suggests it's a large effect size, but if we want to be more confident in this, we would repeat the study with a bigger sample size. Okay? And that is all you need to do the independent T for this activity. All right, good luck.